want to review the summation notation. So let's see, where are we on here? We are on page 3, and it's talking about summation notation. Let me repeat a little bit about what happened last time. So you have this big giant thing. Do you remember what this thing is called? It's a sigma. Now this is an uppercase sigma. Greek has uppercase and it has lowercase, just like we do. So an uppercase sigma looks like this. It makes an S sound. So that's why sigma, S. And we're going to kind of keep iterating. It means we're revisiting. We're going to loop through this 1 time, 2 times, 3 times, 4 times, 5 times. So the value of I will start with this thing. So let me just erase what's here so I can kind of restate it without all this confusion here. So when I start, it's 1. And then what you do is you say, well, what is it I am summing or adding? Whatever is in here. Right now it says just the value of I. What's my value of I? 1. This means add stuff. Sigma means add stuff. So put a plus. So now I'm going to loop. But every time I loop, your I value bumps up by 1. Now my I value is 2. And I'm going to go back in here and say, well, what is it that I'm summing? In this case, just the I value, 2. Add a plus, because that's what sigma means. I'm going to loop back in. Before I loop back in, my I goes up by 1. Now I'm at 3. I look in here. Oh, I just write it down. Sum it. This bumps up to 4. What's going to go here? 4. Summation says add. Bump it up. Go back in. Oh, just write down 5. Now, when do I stop? When my I value becomes that value. I already did that. So now I'm done. This is shorthand for that. It means the same thing as that. It's another way to write 1 plus 2 plus 3 plus 4 plus 5. And now I can add these numbers up. 3, 6, 10, 15. Yes, sir?
What if it has like 2 I?
All right, okay, so it doesn't always going to say I in there. So let's see what happens if it does say 2I. And this time, maybe I'm only going to go to 3. Do I have to go to 5? No. I go to whatever I need to. And it says 2I. So there's no operator here. That means I'm multiplying, right? So the first time through, what's my I value? 1. This says the first time through, you've got a 2 times a 1. Add a plus, I'm going to dive back in. But what happens to my I value? Bumps up 1 to 2. So now I've got 2 times 2. Put my plus in, jump back in. My I value bumps up to 3. What do I put here? 2 times 3. Now do I bump it up anymore? I stop because I've reached my end limit here. So I've got 2 plus 4 plus 6. 2 plus 4 is 6 plus 6 is 12. This is another way to write the number 12. Well, that's a real complicated way to write the number 12. Okay, but it is another way to write the number 12. Let's try a different one. I'm going to do now K. How about K equals 2 to 4 of K squared? So let's see if we get what's going on here. Wait a second, but it doesn't say I anymore. It just means if this is a K, look for K. So you look for matches. What is K when I start? 2. So I put that in there. What do you do with the K? You square it. Put a plus in, dive back in. What is K now?
3.
3. Plug it in here. Square it. Add a plus. Jump back in. K is now 4. Square it. Do I keep going? No, I stop. So this becomes 4 plus 9 plus 16. And it was 39? 39. 29?
30.
39, isn't it?
No, 29.
Okay, so that's summation. So it's a very complicated, I mean, listen, it's not hard at all. Look, between you and me, is this that hard?
No.
Show this to somebody and I'll show this to your folks. They're going to go, I have a genius here. Look how smart you guys are using all the summation stuff. It makes you look very, very smart. It does. But is it that hard? You're adding stuff. You're adding stuff. Question?
So that row number that's like on top of this thing,
Uh-huh.
do you keep going between like 5 numbers or 36 numbers?
That's a great summation? That is such an awesome question. Do you stop before you get there or after you get great question. Let's look at the example. So it becomes 4, you do what you need to do, and then you stop. So does that make sense? So the K will be 2, the K will be 3, the K will be 4, and then stop. Right? That's actually a brilliant question.
So
yes.
K starts at 3 and you're supposed to go to 6. You start at 3.
3, 4, 5, 6. Yeah.
I was looking at the example. In the second one, why is the number before the
Okay, so this, first of all, let's walk before we run. So this is what summation means. It means add stuff. It's all it means. So now we're going to kind of, let's bump it up a notch. This is like, what? So first of all, we don't know what this means, but let's see if we understand what it's saying. Here's my I, here's my I, and it's below the X. Maybe we don't know what this means, but can we actually make a substitution? When I is 1, right, what happens to the X? It's X with a 1 on the bottom. We put a plus, we jump back in. My I value is now 2, right? So that means you write X with a little 2. And we don't know what this means yet, but we're just doing it because that's what this means, right? And I keep doing this for how long? Until I get to this mystery N. Now, do you remember what N means in statistics? What does N mean?
Like the amount of numbers you have.
The number of numbers in a data set. So if I have a data set here, what's N? 1, 2, 3, 4, 5, 6. So how long am I going to do it for that data set?
6.
6. I mean, does that make sense? Let's just get this far, even though we don't know what it means necessarily to have that little number down there. Do we see how this expands from that? Please raise your hand if you're not seeing it. Because, this is one of those things that has to turn on. And then once it does, you're going to be fine. Yeah.
So the numbers inside the bubble, it wouldn't matter if they were the quantity of the numbers or what the numbers are.
Like right now, all I'm doing is substituting in my I. So I'm just saying we understand where this came from, even though I don't know what this means. Yeah, that's all I want to say. This is what summation means. You see the I, replace it with its value, and then you loop around. So I just want to know, I know you don't know what this is, but does it follow based on what we think summation means?
Yes.
All right. Now, what does this mean? Now, when we talked about statistics last time, there are certain things that are like by convention, like N always means the number of points in the data set. Well, you know what we call the points in the data set? And we mentioned this last time, they're always X. So data points are always called X. Yeah, I know, that's confusing, isn't it? Because how do I know which X you mean? Give me the value X. I'm like, well, which one? So what we do is we put these little subscripts. I'm going to call that one X sub 1. Calling this one X sub 2. I'm using that word sub because it's a subscript. It's below. X sub, because I don't always know the numbers yet. So hang on for a second. So now I know which X you mean. So if I'm looking at this data set and I say X sub 4, which one am I talking about? 10. So let's go back to this now. What's X sub 1? What's X sub 2? What's X sub 3? Right? What's X sub 4? Yeah. So what does this mean about this data set? Yeah, what am I doing to all these numbers? I'm adding them up. This is how we say add up all the numbers in a data set. Let that sink in for a second. Oh, is anybody getting a little click? Is a little light bulb for anybody?
Yeah.
Is anybody's like, I'm pulling on the channel, my light bulb, nothing's turning on. Right? What? Ask a question. It's like, wait. Yeah.
Why do we have to do the step with like the x1 plus x2?
Why are we doing this?
Why can't we just add
Why can't you just say add it? That's a great question. We're going to get to that in 1 second. Hold that question. I like that question. Why? That's a great question. But first, let's see. Do we understand what I just did? What if, I forgot what I got here even. Yeah, okay, that's just explaining it. We're talking about it, I think better. What if I had a different set of data? I'm going to call it T, and it was 5, 7, 9, 12. Can I use this same notation to mean what? Add the numbers. First of all, what's the N for this one? 4. It's going to be x sub 1 plus x sub 2. Right? And then I get 5 plus 7 plus 9 plus 1. So now all I need is one thing, and that expresses for any data set, add the numbers. That's why I'm doing it, because now I can have a general rule. If I need to add numbers, I can write it like that, even if I don't know what the numbers are. It's just saying, for example, can you think of a case where we add up numbers, and I don't know, maybe we divide by the number of numbers we have? Mean. Yeah. So can I write a formula for mean that will work for any set of data? How would I do that? Well, I add up the numbers, right? There I am adding up numbers. Then what do you do? Ryan, then what do you do? Look at this guy. Look at this guy. Do we see this? That's brilliant. That is, do you see what he did? He said, I know what mean is. It's you add up all the numbers, you add up all that you have, and I have n, and then I divide by n. Does this, who makes, raise your hand if this makes sense to you. Now, if it's not making sense, you can say no. No? No. So let's do like this example here. So I'm going to use just a smaller one. So if this is my set of data, 5, 7, 9, 12, right? So let's expand this out. This says add x sub 1 plus x sub 2 plus x sub 3 plus x sub 4, right? Isn't that what that means? My n is 4. And then what am I dividing by? 4, because n is 4. And that says, well, I know what x sub 1 is. I know what x sub 2 is. Oh my goodness, isn't that mean? Yeah. Oh! So the reason we're doing this, to get back to your excellent question, is I now have a way of writing a formula for mean for any set of data. Any set of data, this will work. Yeah? Who's with me? Come on, who's with me? Who's, everybody's like, I'll just say it because then you'll stop. No, ask a question if you're like, what? Yeah.
Like, when we're actually using this, would you only use this in like one situation? You have to show a formula for the mean
We're going to use it in different ways. This is a formula for me, but we're going to get some other formulas. So let's do that. Yeah, question. Well, I'm replacing it because for this data set, what is x sub 1? 5. What is x sub 2? Right, because I have to call them all x. That's the statistics rule. So I kind of give them this little, it says what order. Where is it? Where's its location in the data set? So I know which x I'm talking about. Let's try these U-tries here on the bottom of, where is this? Yeah, bottom-ish of page 3. Let's just try this. And we actually, we did this one already. Let's see if you can do it. I do still have some people writing, which is okay. But look up and see if what you've done so far is correct. Is it always going to be this easy? Yes. I don't know. You know, some people find some things easier than others. This is really not hard. It just looks hard. Look how hard this looks. Yeah, I was doing this once, and one of our assistant principals walked in several years ago, and he was like, what? Like he couldn't do it. So there you go. I don't know. Okay. Any questions? Yes, sir. D. All right. So let's remember what this means. It says I equals 1 through n. Well, what's n? Cole, what's n? 4. 1, 2, 3, 4. So I could rewrite that as I equals 1 to 4 of x sub I. Well, replace your i's. That's x sub 1 plus x sub 2 plus x sub 3 plus x sub 4. Yes? So far, so good?
Yeah.
What does that mean, x sub 1?
It's 8 times 1.
8. No, it's not a times, it's not anything. This 1 just means your first x. This 2 just means your second x. So I'm not multiplying, I'm not squaring it, right? That's why it's below. Why didn't I put it above? Because that would look like squaring or cubing. I'm not doing that. What's the first x? Add. What's the second x? Add. What's the third x? Add. What's the fourth x? There's no operation implied, it's just plop the number in. That's all it is. Hey, excellent question, really good question. Anybody else with any kind of confusion with that? Yeah. Huh? See? So let's see, that one is going to be, I is 1 when I start. So 1 plus 1 plus 2 plus 1 plus 3 plus 1 plus 4 plus 1. One more, right? Oh, I'm running this mess a little bit. So then that's 2 plus 3 plus 4 plus 5 plus 6. Yeah, 5, 9, what is that, 20? Yep. Yeah. Okay? So definitely expand it. Try not to do these in your head. I'm telling you, it'll just mess you up. Just write them out. Okay, awesome. So the reason that we went through all this is, and I hope you see why we have a very general rule for how to find the mean of a number now. I'm going to rewrite the mean absolute deviation using the summation, because look what MAD is, and we talked about this. You find each x minus the mean, take the absolute value, add them together, divide by n. Well, remember what adding together is? That's summation. So here's the formula for mean absolute deviation. Let's see if we understand what it says. I equals 1 through n still means the number of numbers, and I'm going to be dividing by n. I'm taking a mean, right? Add up stuff, add numbers, divide by n. This is a special case of this, except what am I averaging? I'm taking each x, because x of 1 minus the mean, x of 2 minus the mean, and adding it. So if I have a simple data set, let me make it even simpler so I don't have to figure out what the mean is easily. Okay, what's the mean of these numbers, 2? Right? So let's use this. N is 3. It says, okay, I'm starting with x of 1 minus the mean, plus x of 2 minus the mean, plus x of 3 minus the mean, all over my n. First of all, there's this is hard to read. That says x of 3. All right, I expanded this for n equals 3. In fact, I can make that 3. Question on how I got from here to here with this data set. Okay, wait. What is x of 1? 1. What's my mean? 2 plus. What's x of 2? 2 minus my mean plus x of 3. I'm running out of space. 3 minus 2. This is the distances. That was that step where I said find the distances and take the absolute value. What's that step? 1 minus 2 absolute value is 1. 2 minus 2 is 0. 3 minus 2 is 1 over 3. 2 over 3 is my mean absolute deviation. So if you get this, now sometimes this takes a little bit of thinking. Like, okay, this formula you may use on the test. This formula can be used on the test. If you get this, you have to memorize MAD. Now really, this formula will be available when you take the SOL exam. So that's going to be in May. That's like almost far away. You may not remember this, but if you understand what this means, you can use the formula sheet.
Like,
Oh, now we're getting angry looks. What?
where's the test on this?
What? What?
Where's the test on
It's on the board, October 15th.
Oh, I was right.
Alrighty, so that's MAD. And so what I want to do now is I want to kind of move along a little bit here on this. So we're going to look at something called variance and something called standard deviation. Okay. I'm saying here another way to work around the problem of negative deviation. What am I talking about? I don't know if you remember this. When we first did MAD, right, we had those kids in the family, right? And we averaged the distance between their ages. And remember, before we took absolute value, do you remember what the MAD always came out to be? 0, right? Because, you know, you'd have an equal number. Here's your mean. That's the middle. So there's going to be an equal number below, equal number above. If you average those distances, you always get 0. So mean absolute deviation, their solution was take the absolute value. there's another way to look at it. So that's one way to find average distance from the mean. Another way is to say, listen, this is a problem because whenever I add up distances, it's always 0. How about I squared them? Now think about any number squared. I'm just going to say x squared. If x is a positive number and you square it, do you get a positive number or a negative number? X is positive. Positive. Okay, listen to this now. What if x is negative? And you square it. Like if I have -1 squared. -1. What does that mean? It means -1. Right? What's -1 times -1? 2. Who said 2? -1 times -1 is 1. Whenever I square a number, well, I guess it could be 0, or it's going to be positive. So one school of thought said, well, don't worry about absolute value. Why don't we just square these distances? And then take the average of that. So they said, okay, let's do that. And let's call it variance. Okay? So this is what it looks like. Like, oh, no. Well, no, we're not afraid of this anymore. It says I equals 1 to n. For all your numbers, you're going to take the x and subtract the mean and square it and add them together and take an average. Now, we call this variance. Now, here comes the Greek. Remember this sigma? Uppercase. This sigma, lowercase. Both called sigma, both mean different things. Sigma with a little 2 up top, sigma squared, is the statistical way to say variance. Sigma squared is variance. It's this. Instead of taking absolute value, I'm going to square it. And we're going to look at an example to hopefully make this a little more clear. Please do. All right. So here's a set of data. And I've already found the mean for us. It's 5. But remember, now it's not like, can you find the mean? I know you can find the mean. So here it is. I'm going to use a calculator for that. First thing you do, like we did before, is x minus the mean. So here's, I'll put it where I can see it. What's 1 minus 5? Let me just see if I can get you on the right page so your phone will go on. I think this is on here. You should be on page, what is this? 4, right? Page 4. And it's example 1 on page 4. So what is 1 minus 5? What is 3 minus 5? Right, that's x minus me, that's what I'm doing. What is 4 minus 5? 1. 6 minus 5? 1. 7 minus 5? 2. 9 minus 5? 4. Okay, now, we're mad, we just made them positive, right? This is not mad, this is variance. And it says square the number. What's -4 times -4? 16. -2 times -2. -1 times -1. 1 times 1. 2 times 2. And 4 times 4. Right? This is different from that, where we just made a positive. Now I'm squaring them, all positive, right? I don't have to worry about adding these up, but this will add up to 0. These won't. And now I find the mean. See, I just did this part. Add them now. You like it better with the formula? Or you like the table?
I like the table better than the formula.
Oh, what's my n? N is 1, 2, 3, 4, 5, 6. The good thing about the formula, though, is you're going to have it in your hand. So if you make that effort to, like, you know what, I can do this, you don't have to memorize this stuff. Anybody have this ortho science? Is she doing this stuff with you? She is.
Yeah.
She is. Okay, should she do all this? No. All right, so let's see. We got that. So what does it come out to? Oh, goodness. That's 20, 21, 22. Adding another 42 over 6, which is 7. The variance, or sigma square,
Yeah, you did over 6.
because it's a mean. I'm taking a mean of this, and I've got 6 numbers. 1, 2, 3, 4, 5, 6, and a 6. Right? That's how you take an average. Right? Adding them up, dividing by the number I have. And so that's variance. So variance is another way to kind of measure how far from the mean, except for one problem. It's isn't this a lot bigger than like math would be? Let's see, what's math again? Math would be just taking these, right, 4 plus 2 plus 1 plus 1 plus 2 plus 4 over 6. Right, this is math. 7, 14 over 6, which is 2 point something on it. 2.3, I don't know what it is. A big difference. Now, the idea is I want to measure the same thing, average distance from the mean. This is big. So what do you think we can do? Well, what are we doing here? I'm just going to go to this thing. So variance on its own, it's not good because I'm squaring numbers. I'm making the distance artificially big. So what's the opposite or the undoing of squaring? Square root. So they say, yeah, this is too big. Why don't we just take the square root of that number? Since I did so much squaring, I'll take the square root of it. And then sigma squared, which is variance. What's the square root of sigma squared? Think about that. Sigma. And that's what we call standard deviation. So if you've been working with this in science, maybe they just gave you the formula. How do they do this in science?
They give us the list of numbers, and then
Did you just do this method? Because you would have to go through all this rigmarole. It's a lot of work. So, okay. So, why do you think we take the square root of variance to get a standard deviation? Because we want the average distance from the mean. When you square numbers, especially as the distances get bigger, you get a huge number. So we square root it to kind of get it down to a more reasonable size, closer to MAD. The important thing to remember here is that MAD and standard deviation are different ways to measure the same thing. On average, how far are the points from the mean? And again, let's revisit. If you have a big MAD or a small MAD or standard deviation. So let's say it's a big number. What does that mean? And then what does it mean if it's a small number? Yeah, what does it mean if you have a big giant MAD?
that means that numbers are not close together like 100 and 1.
Yes, so they're not close together. What if you have a very small MAD or standard deviation? They are close together. Okay, they both are different measurements to give us the same information, but it's different ways of finding it. Some people like the standard deviation. It will always be a little bit bigger than MAD, and they like that little bit of room, you know, just in case we call that like an error. What's a good way of saying it? So that you know maybe you're erring on the side of too much, but you'd rather have a little bit too big than not big enough. Mostly we use standard deviation over MAD, but I think MAD's a little bit easier to understand. So let's find the standard deviation now. By hand. Okay. Oh no. So here it is. This is the formula. Oh my goodness gracious. What are we really doing? We find the mean, that's mu. If you find the mean of these numbers, add them up, divide by, what's n? 1, 2, 3, 4, and 6 again. I get 12. So I'm going to do x minus 12, right? Here's my x of 1, my x of 2, and so on, right? 0 minus 12 is negative 12. 10 minus 12, negative 2. 11 minus 12. Where'd everybody go? Here.
I'm right here.
Oh, okay, I didn't hear you. What's 14 minus 12? 2. 15 minus 12?
3.
And 20 minus
8.
12. Okay. So now I got to square these things. What is negative 12 squared?
44.
Negative 2 squared. Negative 1 squared. All right, so that's the x minus means. Now it says add them up. Okay. All right, I'm going to add them up. And then it says divide by however many you have. Well, that's 6. Oh, somebody's going to have to do this for me. What is that variance? See what you get. Hopefully you get the same thing. 226 over 6. If I turn that into a decimal, I think that one was approximately 37.7. Let's make it that. Variance. Ooh. This is variance. Now, is this standard deviation? No, because what's the last step? Take that square root of whatever number you get here, and that is approximately 6.14.
What? The square
Isn't it?
root of 37.7 and 6.1.
Approximately. Well, what's 36? What's the square root of 36? 6. I think that's probably, that's probably right. Who followed? Nobody. Uh-oh. Maybe one person.
This one,
I did.
This one you can
Okay.
actually, this
But
one you
then
can
I got
actually
lost.
definitely don't have to like apply it.
Yeah, when we're working with statistics, very often we are using these numbers as decimals, like a real life application, we tend to use decimals more. When we get back to pure algebra, we'll go back to our fraction. Okay, so a lot of work. Okay, so hang on here. Now, we actually did do this data already. These are the ages of those kids. Right here's the baby, 0, right? So we calculated MAD to be 4.7. Now, let's look at our MAD, and let's look at our standard deviation. What do you think about those numbers? Standard deviation's bigger. Is it crazy much bigger?
No.
No. Now look at variance. That's crazy bigger, right?
Yeah.
So these are not good things to compare, but these kind of are. So they are measuring the same kind of thing. What is the average distance from the mean? One method will say it's 4.7. Another method will say it's 6.14. Pretty close. Your MAD and your standard deviation should be pretty close. When your data is very far apart, you see a bigger difference because of the squaring. You will see a bigger difference, but it's always going to be a little bit bigger. So, again, they measure the same thing in different ways. So if you're finding MAD and standard deviation for a set of data, they should be close. If they're not close, there's probably a mistake somewhere. And what does close mean? It's hard to say. But 4 and 37, not close. So you want to kind of use that as a little check. All right. Okay. So here's mean absolute deviation. Measures average distance from the mean. So what you do is you find the mean, you find all those distances, x minus mean, take the absolute value, average those distances. And that's what this means. That's what this is telling you to do. We have variance that says I don't want to take absolute value of those distances. I want to square them. And then I'm going to average all those squares. Fine. And then you have standard deviation that says, well, once you get variance, take the square root, and I've got a good measure of average distance from the mean. Doing the same kinds of measurements in different ways. Who's kind of with me so far?
I lost you.
Okay, you lost me at variance. So what's your question? Where did I lose you?
At the
Huh? That's not a no, that's a lowercase sigma. And I said call it sigma squared because sigma is standard deviation. If you square sigma, you have variance. And it's just saying, because if you average distances, you get 0, I have to somehow get a positive number. One way was to take absolute value. Another way is to square the distances. Both cases, I'm taking the average once I do that. The problem with variance is because I squared the numbers, they're big now, so I take the square root of it to get it into a more manageable size. So it's complicated. Let's see, am I ready for good news yet? Yeah. I've got some good news for you. Well, first the bad news. Bad news and good news. Bad news, this one hard on the calculator. But, you know what, this one's relatively easy to calculate. Don't you think you did this for homework? It's not too bad to do this one by hand. What do you do? It's easy. Well, if you can remember it, there's a ton of steps.
The math one I remember.
Okay, but I'm telling you, there's a lot of steps. And come May, when we're doing this again, you're going to be like, what? These, however, hard to calculate by hand, easy on the calculator. So, hooray, right? That's why this says, woohoo, hooray. Look at that. We can use the calculator to do our work. So, have you got your calculator? And then, now the thing about this is you look at it, you go, what? What is that? So, you might want to make your own notes. You may want to make your own notes because this looks like, look. So finding standard deviation, we're going to find the standard deviation of all these numbers. Imagine doing this by hand. You have to find the mean, then you have to do all those subtractions, then you'd have to square all those distances that you found, right? Then you'd have to find the average of all those squares, and then you'd have to take the square root. For all these numbers, what's n here? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 14. So how long would you be doing this? I'd come back tomorrow, you'd probably still be doing all these adding. I do not want you to do this by hand. Look at that. Don't do it. What kind of a direction is this? What? The point here is not can you find a standard deviation, but can you use it? So we want to find it as quickly as possible. Yes? You're going to have a little trouble if you don't have one of these calculators at home. You can come during your resource and sit here if you want and do it at school. It is really difficult without the calculator. Now, oh, I've got this new little calculator application. Let's see if I can do this. So what you want to do is enter your data, right? List one. So stat, edit. Everybody doing this? Oh, there's stuff in here. All right.
Whoa, that one was cool.
Yeah, this one is more the 84. I have my other one up as well, but they gave us this one. Okay, let me see if I can work this out. So let's put the data in. 40, 50. Right, you're doing this too, right? 35, 60. 38, 42, 47, 90, 55. Oh, wrong. 52 and 75. Again, I'm going to ask you to please not talk while we're doing this so that we can all hear. I always check my data. Garbage in, garbage out, right? So just make sure it's right. 40, 50, 35, 55, 62, 75. I think I have it right. Okay. Now this thing, let me see if I can remember what I have to do. This one's kind of cool. It tells me the key press, but it also lets the screen be a little bigger. You can't see it. So now, stat, calc, one variable statistics. If you have the black ones, it doesn't have this little menu, but it's the same thing. L1 if it doesn't already say L1, or you can leave it blank on the older ones, the 83, and then hit enter. So here is my mean, correct?
Yep.
Is that what we're getting? Yep. So approximately 53.3. But wait a second. Look up, folks. Now, maybe we can recognize some of this stuff now. Here's a little sigma. What do you think's going on here?
It's sigma regular, and then there's sigma times 2.
Oh, wait, what's this one? What do you think 746 is?
It's added.
It added all the numbers for you. This one says square the numbers. I don't know what we want to do with that. Well, you square them and then add it. And then this now, there's two things here, an S with a little x and a sigma. That's what that is, a lowercase sigma with an x. Which one is standard deviation? Which one? The second one? You know what? The trick answer, trick question, they're both standard deviation. Now, this first one, standard deviation if you're working with a sample. This one, standard deviation if you're working with a population. For our class, everybody listening, we are not using samples. Don't even look at the one that has the 17. What is the standard deviation? Approximately 16.5. No fuss, no muss, there it is. Or you could go do this by hand for like 3 hours. Which one do we like better? By hand or calculator?
3 hours.
We like 3 hours. You're the only one. So this is how I want you to find standard deviation. I don't want you spending all that time with all that little stuff. And how many little mistakes you're going to make? Probably a lot. Right? What's the standard deviation? 16.47. How easy is that?
Really hard.
Quiet. Please don't talk when I'm talking. All right, now variance. Now when you do it by hand, you find variance first, right? And you take the square root.
The standard deviation is the square root.
That's right. Now I'm starting with standard deviation. That's the easy one to fix, to find. It doesn't give me variance. How can I get variance if I know the standard deviation?
Multiply it times 12.
Yeah, or you square it. So think about that. So if you know that standard deviation, I'm going to pick an easier number, is 4, say. What's the variance going to be? 16. Right? So when you start with that, you square it. If you have the variance first, you take the square root. Please stop talking. Now watch how you can do this on a calculator. Your first choice would be, whoops, to say, well, why don't I just, get an approximation. I think it's around 16.5, so I'm going to square that. Do you see the square button over here? You've looked at it before, but it's still here. Up 1 from the 7, move left. That's an approximation. Now I can get an exact variance doing the following. So look up and watch first. Okay, look up. You see this little bars? Okay, look at your clear button. Don't press it, but look at it. And look 1 to the left. You see where it says bars? Press the bars button. Bars is where it stores, and please stop talking. Bars are where it stores things that the calculator has found for you. So when we ran our one variable statistics, all those things that flew by, it stored. Right here, see number 5 where it says statistics? If you press number 5, these are all the things it calculated when it went scrolling by, and you can get to them again. So if I want to find the standard deviation, here it is, number 4. And then I can square that, and I'm getting a more precise variance. So when I find variance, I press bars, I press number 5, I press number 4, and I square it, press enter, I found variance. If she's like, that is way too much to me to remember, you can use the approximation and square that as well. It just won't be exact or as close. Make sense? Yes. Questions? Okay, so that's what this is trying to tell us. It says to find standard deviation, you just put it in the list, do your stat cap 1 bar stats, look for the sigma x. You found it. If you want to find variance, do this first, square that number, or press bars, number 5, number 4, and square it. So if this is too many words, you can always put this in your own words. Yeah?
Find variance and do standard deviation.
Yes, do the standard deviation on the calculator and then square it. If you're doing it by hand, it's the opposite. You're going to get your variance first and then take square root. But there's no reason to do it by hand.
So you take the deviation and square it?
Yes. That's why we call it sigma is standard deviation, right? Sigma squared. If you look at your formula sheet that I just gave you, it tells you that this sigma is standard deviation. Look at your formula sheet. You see where it says sigma is standard deviation? Anybody looking at it? Yeah, you should all be looking at your formula sheet because I just told you to go look at it. Okay, it will tell you this is standard deviation and this one with the square is variance, right? You see that? So can't we see that you can just square this to get that? It's trying to tell you how it works. All right, now mean absolute deviation. I did this real fast last time. I hope these are the same numbers, right? How do you find mean absolute deviation? Okay? This is optional. Know how to find a MAD by hand. Because these steps are things that are hard to remember. There's a ton of steps. So I say if your mind's about to explode because there's so many steps, just do it by hand. And even if you think, oh, I got this, still know how to do it by hand because come May, you'll be like, oh, what was that thing we had to do? Okay. So here's how you do it by hand. So you say stat edit, you put all your numbers in. We've done that. Okay, this is a very important step. If you don't do your stat count 1 bar stats, this will not work. So you have to run your 1 bar stats. It's storing all this number in the variable. All right, is anybody doing this with me?
Yeah.
Anybody? Okay. Then we go back into the list. Stat, edit. Okay, now here's the tricky bit. Y'all doing this with me? Get that finger memory going.
Yep.
You with me?
Yes.
All right, I want to go to L2. Press the right button, press up, press enter. See how I'm blinking down here? Okay. I want to take the absolute value, right? Mat is absolute value. If you press the mat button, and under this num menu, so I move one to the right, see where it says absolute? You press enter. If you missed it, just hang on then, just watch. All right, what am I taking the absolute value of? The values of the things in list 1 minus the mean. That's xi minus m times mu. So I say I want list 1. Press the second button in the 1. List 1, press the minus button, the mean. Now we just calculated mean. So we're going to use the vars key again. Press the vars. I want to look at my statistic values again. And then I'm going to press number 2. This time I want x bar, the mean. See how now it's here? Optional to put the little close parenthesis there. Yeah, isn't this x1 minus mean? Okay, when you press enter, hopefully, here's all the distances for you. It finds all the distances for you so that you don't have to do it by hand and maybe make a mistake. Now, how do you find that? It's the average of the values in this column, right? These are distances. You want this average. So I do a stat, I do a calc, I do 1 bar stats. But do I want to use list L1? Nope. Second L2, and then I will press enter. X bar, my average, 13.9, right, approximately, is the mat. Mat is approximately 13.9. Now, it's a ton of steps. If I look at the key press, look at all the things you've got to do. Are you kidding me? Right? It's a lot. Now, some people are just good with these little technology things. They get it. You do this like 2-3 times, it gets in there. You can do it, and you'll remember it. But, will you remember it, 7 months from now? I don't know. Maybe. So you have to understand how to do it by hand. You do have a formula. So this is your option if you want to try it. Now look how complicated this is. If you want to put your own notes in here, you can. All right? It's trying to tell you what to press and what to do. So what do you think? Questions? You okay? It's easy? All right. Well, let's see how easy it is. So where is this? This looks like bottom of page 4. So for these, I want you to find the mat, the standard deviation, and the variance. So implied varies, you're going to have to find the mean as well, right? You're going to need that. So find the mean as well, why not? And then we'll talk as you're working on it. All right, I put up answers. Did we get through the first one?
I didn't.
No? Where are we getting held up?
I got through.
All right, let's do one real quick. Let's start from scratch here. So I'm going to clear out my list. So go into your list. I'm going to clear mine out. So I have to enter my data. All right, if you guys are working over there, that's fine. Wow, that's not what I want. Whoa. Okay, so 10, enter in list 1, 30, 40, 50, 60, okay? Check that you printed the data right, 10, 20, 30, 40, 50, 60. You're going to run stat, calc, 1 bar statistics for list 1. Okay, are you watching? If you're having trouble with this, you're watching. What's my mean? 35. What's my standard deviation? 17.08. 17.08. If it doesn't say how to round, round to the nearest 100. So I'm halfway there. Now I want to find the variance. You can either square 17.08 and square that, or you press the vars button. It's right to the left of the clear button. Press number 5. I want the standard deviation, that's number 4, and square that number. 291.67 is your variance. Okay, so those are the ones that are relatively easy to find. Now if I want the mat, I'm going to go the max button, move over one to absolute value, because I want the absolute value of the deviation. Everything in list one minus the mean. Well, I already calculated the mean, it's stored in the bars. So bars number 5, the mean here is number 2, X bar, and then press enter. Now, if you did this and you get error, it means that you didn't run the 1 bar stats that stores the X bar. These are the distances from the mean. I want the average of these numbers. Stat calc 1 bar stats of L2. Because now I want the average of the distances. And I'm getting that to be 15. And then I look at my standard deviation, I look at my MAD. Are they about the same-ish? Are they close? They should be. They should be close. They won't be the same. Standard deviation will be a little bit more because of all the squaring. This one, not it, right? Look how different they are. So this one can't be your standard deviation. Question, yeah.
Oh, I didn't do all that, like, all those steps on the calculator, I just did by hand.
If you do that by hand, that is absolutely fine. Doing that by hand is fine. Those calculator steps for MAD are optional, not optional for standard deviation or variance. Use the calculator for those. But yeah, if you're like, I'm not doing that, it's too much, that's fine. Yes? You press the math button, and then you move one to the right, and then it's the first choice on that move. Okay? I think that's all you need to know. Now it's more practice just for you guys.